Hello everyone. Today we are going to solve the problem that is problem of the day of Leetcode. So the name of the problem is maximum value of an ordered triplet 1. Okay. So I have made the problem statement in simple words, like in order to explain you guys in a better manner. So basically let's jump to the problem statement. We have been given an array nums of integers. Our task is to find the maximum value possible for the expression. The expression we have been given as this: nums of I minus nums of j into nums of k. So this expression, we will be given an array as given. So we have to put the element, and we have to return the output as the maximum number comes out from this expression. Okay. So where the here it is also written where the indices must satisfy the condition, that is I should be less than j and j should be less than k, and if all the possible triplets give you a negative value, we should return 0. So in simple words, what it means is we don't need to entertain the negative values. If all the all possible triplets give a negative value, we simply return the result as 0. Let's see from the example 1 what it is given. We have been given a nums array, elements are 12, 6, 1, 2, 7. Okay. And the best triplet which can be formed, that is the maximum value of an ordered triplet, can be made from the index 0 to 4. So at index 0 there is 12, at index 2 that is 1, and at index 4 that is 2. Right? No. At index 4 basically 0, 1, 2. Yeah, at index 4 that is 7. Okay, so at what we can see is now it's time to put the values, like at what is there at 0, 2 and the 4th index. So what we can do, 12 minus 1 into 7. So the answer we get is 77. You all can hit and try. You can see the maximum value of an ordered triplet will be 77 only in this example. So the maximum value possible is 77, and that is the thing we need to result as an output. Okay, let's see example 2. What is there? Basically we have been given nums again. Now the example is 1, 10, 3, 4, 19. These are the array elements. Again, the best possible triplet can be here. The best means the maximum value which can be maximum value of an ordered triplet satisfying this expression, and where I should be less than j and j should be less than k. Basically I is less than j and j is less than k. This condition should be satisfied. So what was there, best triplet can be from the index 1, 2, 4. So after putting the values we get 133. So this will be the maximum value which can be formed out of this expression and satisfying this condition as well. Okay, so that is 133, right? Similarly in example 3 we can see the only valid triplet is 0, 1, 2. So 1 minus 2 into 3, because 3, if 3 only 3, this is the basically edge case. If there is only 3 elements, so we can say here 1 minus 2 into 3 is equals to minus 3, which is negative, and we should return 0, right? So what can be the brute force approach? So brute force approach can be very simple, like we can iterate over all possible triplets first from 12, 6, 1, then 12, 6, 2, then 12, 6, 7, then again we will change 6, 1, 2, 6, 1, 7, 6, 1, 12, like this. Okay, so let's see the proper method of brute force, how we will do. We iterate over all possible triplets I, j, k, and we will calculate the expression for each triplet. Now what can be the algorithm? It's quite simple, like we will initialize the max value should be 0 since we ignore negative values. Okay, now we will use 3 nested loops to check all possible triplets. Okay, after that we will compute the expression by putting the values, right, which I have given you. This expression is given, we have to put the values in this expression, right? So if the value is positive, we will update the max value, and we need to return the max value like this. But the solution is quite simple, which I discussed right now. But the time complexity, if we see, we are using 3 nested loops iterating over n. So you all can see the complexity will be, time complexity will be O of n cube. And space complexity, we are not using any extra variable, extra space, only a few extra variables we are using. So it will be constant. So it's time to think Is it a better solution? No, because the time complexity is O of n cube. And why this solution fails? I will tell you. Like if the n, that is the input, is 100 and the worst case will be 100 cube, like n cube. So there will be how many iterations you can see? 10 lakh iterations, right? Then the solution will be too slow. So we have to think something better solution, okay? Optimal solution we can say. So now it's time to think of an optimal solution. I have written it over here. I will explain you right away how we will do. Basically the approach is quite simple. Nothing too complex. Like we have to break this formula, like right? Nums of I minus nums of j into nums of k. So let's understand. A large nums of I before j, okay, that is we have to maximize nums of I, right? And we have to basically think of a combination which suits well for this expression in order to bring the solution maximum, like our output maximum. So what we can think from our inner self, right? Like what we can do is basically we can take the large nums of I before j, that is maximize nums of I, and small nums of j. This combination should be there. A small nums of j in the middle, that is minimize nums of j. Because why we are doing so? If we subtract something from maximum value to minimum value, the difference will be so large. Suppose if we have a range of 1 to 20 numbers, okay, 1 to 20 numbers. If we have a 1 to 20 numbers, then what we can, if we want to get the maximum difference, so what we will do is basically we will take the maximum value, that is 20, and we will take the minimum value, that is 1. Now we will subtract it, like 20 minus 1, that is 20 minus 1 we will get is equals to 90. So this is the maximum difference we can get. So that approach only we are taking, like a large nums of I before j, which will maximize nums of I, and the small nums of j, because we have to subtract, right? We have to subtract j from the I. So now it's time to think like a large nums of k, because we have to multiply, right? We have to multiply with the difference of these. We have to multiply the nums of k with the differences of this, okay? So what we can do is basically after getting the result of this, that is the maximum difference, okay, after that we have to multiply it with nums of k, that is maximize nums of k. So the optimized strategy will be like we will pre-compute the max prefix I, that is the maximum value from 0 to I minus 1, and we will also pre-compute maximum suffix k, that is maximum value from k plus 1 to n minus 1. Do not worry about this part, I will tell you in code also. It will be much easier as you think, like no need to be worried about this part. I know some people like don't get this, how this will work. I will tell you it. Now the third part is we have to iterate over j, that is the middle index, and we have to calculate max prefix j minus nums of j into max suffix j efficiently, right? So basically this max prefix is basically the maximum value from 0 to I minus 1, and this suffix k is basically the maximum value from k plus 1 to n minus 1, okay? So the time complexity for this solution will be like prefix and suffix max will take O of n, because we need to search every element, and then we need to come out of an outcome, okay? Then again we have to take like single loop over j for like O of n, okay? After that we have to like total complexity will be O of n, and space complexity will be like we are using two extra arrays, that is max prefix and max suffix. So the maximum space complexity will be O of n, okay? So this was the optimized approach. Now let's come to the code part, okay? I'm going to tell the code part. So this was the Leetcode interface, which we are given with maximum triplet value, that is the function. And here first I have broken down into three main steps. So basically first of all we need to create the prefix max array, okay? So this is the syntax for array creation, like prefix max array creation. We created in the form of vector. Then we have initialized like max prefix 0 is equals to nums of 0. Then comes the like for loop for storing the max value from 0 to I. Okay. Now similarly we will create the suffix max array. Similar thing we will do, like this time we will initialize the max suffix n minus 1 should be nums of n minus 1. This was the first element, this was the last element. Okay. Now it's time to run the loop. Basically we will start with n minus 2. We will go till like in the reverse direction, and like for storing the max value from I to n minus 1. Okay. At last, like step 3, we have to iterate over possible middle elements j, that is computing the max value. For this also we will run a loop for maximum element before index j and the maximum element after index j, because we are iterating over the possible middle elements. So we need to take care from like before element and the after element, after index. Okay. After that we need to compute the expression that is given by the in the description. So how we will do that? Basically long value, we will store the expression here and we will put like max left max minus nums of j into right max. Okay. After that we will update the maximum value if a larger value is found. That is max value is equals to max of max value comma value. Then we need to return max value. Okay. So this was the solution. I guess we are breaking it down into the simple steps, nothing too complex. If you guys understand, like if you try to understand the solution, it will be too easy to understand, nothing too complex. I will share the code as well. Please have a look and try to get like what I'm trying to tell you all. This is the simplest, I guess I was able to simplify this question, although there are lots of solutions out there which have some things, advanced things which can't be understood easily, but I've broken it down into the simple steps. And if you guys understood the solution, please hit the like button and also subscribe to the channel. Till then, thank you.